just name it as simple. Inside that folder, I am going to create subfolders. The first is schematic. And the next, board. And next, netlist. And next, Gerber. And if you have data sheet, and we need the footprint. I'll use the footprint which is in the location of 3D project. This footprint, so I'll just use it. This one I copied and gave to you. Okay, first I am going to create the schematic. For that I am going to start and opening the software capture CAS, selecting the arcade capture, OK. In that file, new project, in that schematic, I am going to fetch the location. And the schematic name, project name, schematic project name. This also I will keep it as simple. Then click OK. And next I will save it once. Next, I am going to keep the parts as per the circuit diagram. In that, I have used a connector that named as header, HEA, and the 2 pin I need. So I will just give 2 and press enter. And place and give escape to disconnect. And next I need a resistor, so I'll just press R and press enter, and I place here. Next I need a LED, just I press LED and I'll place it. If you want to change the schematic page properties, we can change here. I'm going to rotate by using R. I'm going to connect the wire using W. Going to give the part value. I have given the part name, part value. I have not changed the reference numbers. Please keep in mind. And I will just save it. Now I am going to place the footprint. So for that I am just going to the PCB editor software and selecting Allegro PCB designer. I am going to use the existing footprint. So I am opening the footprint folder, FTP project. In that I have footprint. In that I need a PTC connector. The name is term. So just I have copy the footprint name and go to the schematic, and I am going to place the footprint name in this location. And next I am going to take the footprint of resistor of quarter watt. So just I will choose the resistor TH footprint name, copy and paste in the PCB footprint region. Next for the LED footprint, just close, save again. Next I am going to the project manager window. In that I am going to annotate first reset part reference. Okay. Then again annotate incremental reference update. Okay. And next design rule check. Okay. In that I am just checking whether any error is found. There is no error. Footprint also we have placed it. And next, select the project name and DRC check completed. Next, just generate the bill of material. In that I am going to give open in Excel, and the location is in simple schematic. Then click OK. Yes, the bill of material BOM has been created. Just I will say once. It will be located inside the schematic folder. Otherwise, we can also get the information from here. Here there is a BOM. If we double click, we can able to view the BOM inside the schematic Capture CS software itself. If you want to see about the DRC design rule check information, we can double click here and we can able to check the details. And next, I am going to create the netlist. So select create netlist, and I need to give the path of the location. So just I am copying the folder location and pasting in the netlist file directory location. Paste and just click once, double click, then click OK. Then we are going to select view output, that's all. Next OK. Yes, after the netlist is being created, here also there is no error. So only these three tabs has been created. If there is an error in the netlist, these three tabs will not be created. If there is error, we have to verify what is the error and we have to clear those errors. And next, the schematic part is done. Then click save. Next, I am going to design the board file. So for that, I am just open the PCB editor software, enter file, new, and there is I think so this will confuse. Just I will close file, new. In that, we have to select the path. So just I will select the location where it is. We'll place over here, and then click browse. I will again paste over here because the location has not been fetched. I paste here and click open. Now the correct path has been identified, and I need to give the file name. File name here also I will just give as simple, and we have to be check that here there is a .prd or open, and the drawing type we have to select board. Then click OK. A empty page workspace area will be created. After that, save once. And after that, I am going to set up design parameters. In that, I am going to set the unit of the thing what I am going to work it off. I am just selecting millimeter. In that width and height of the full workspace area, I am just giving as 500. And I am going to move the origin first to the 0 of the workspace area. So I am copying the older location of origin and I am pasting in the move origin section, then press tab. Again the Y coordinates also I am moving and pasting and press tab. Now the origin is set the 0, 0 as per the workspace area. I am going to move the origin now. I am going to move the origin by 100 mm. So I am going to type X 100. After that I am going to type Y origin of 100. Every time when we give tab, we have to note the status bar. Here it should give the information that the design origin has been moved. And next I am going to display. In that setup grids, in that I am going to reduce the grid spacing 0.001 mm. And then click OK. And then next click OK. Now we can able to see the origin is being placed here. Yes, this is the origin. And next I am going to place the boundary for the board. So that I will just select add line and go to option and select the class and subclasses, board geometry, outline. The line block angle as 90 degree. The line width of 1.5 mm, and line font also we can select, and go to command window and fetch the origin x space 0 space 0 and press enter. And here I am going to choose the approximate dimension of the board. PCB is 50 mm cross 30 mm. So just I am selecting the next placement where I have to place in the command window, or with the x space 50, x direction 50 and y direction 0, and press enter. Next x space y direction 0, x is 0 and y direction of 30 mm, press enter. And then x space y is 0 and x is 50, enter. Now I have placed the x is 0 and y is 0. Enter. Right click and give done. Next I am going to place the mounting drills, so that place for just I will save it. I am going to place the mounting drills, so that go to place manually and advanced setting library, and then go to placement list, that mechanical symbol. Then I am just choosing MTG 250 and placing over here, and then click close. Now I am going to check the pad drill sizes. So I am going to show element and click on the pins, because this is a pin. So I am just selecting the pin, and we can able to see the circle drill is 6.3, but I need of 3 mm drill with non-plated. So just I will edit the pad stack. To do so, I am going to tools, pad stack, modify design pad stack, selecting the pad which I need to edit selected, and going to option. In that pad has been selected, view edit. The pad stack window editing has been opened, and then the drill size finished diameter is 3 mm. I am going to select. Next, tolerance let it be. Next, drill symbol I am going to choose as octagon, and the dimension are the same. Design layers, in that I am going to we are not going to use the pad, but just I mentioned the pad size, then only we can able to see in the visibility in the layout itself. So I give 3 mm itself, the same dia of the drill, so that when they drill, the pad will be removed. No need of pad. Next, the thermal pad and all, I will make it none. This also we no need to do every time. We can able to create a pad in such a manner that 3 mm drill alone is there, and we can able to say our footprint location, and we can able to use regularly. And here also we have to check one thing, there is a units, we have to maintain that. Next, mask layer. No need of mask layer. And go to file and update to design. It has been changed. Update to design and exit. Close. Okay. Here we have the keep route class over here. We no need of this, so I'll just delete it off, or we can able to disable. To do so, I'll just select delete and click find. In that I'll just select shapes and then go to the option. I'll just select the shapes, and if you move the cursor, we can able to see it has been highlighted. Once it is being highlighted, that alone will be deleted. Just click once and click another click outside in the workspace, then it will be deleted. This information is same for whenever we delete any class or subclasses or any pins or anything else. Just we have to select delete and we have to select which we have to select, and after that click at the outside of the workspace area. Now I am going to place the mounting drill at the four corners. So I am going to move the pin. So X space in the command window, X space 5 mm space 5 mm. In X and Y, I am placing the pin in the 5,5 coordinates. And right click and give done. Then now I am going to copy the same pin for all remaining 3 corners. So just select copy and click the pin which we want to select. Here also you can able to see. Now it is being highlighted, the board geometry outline, and the pin also it is highlighted. Because here everything in the option, in the find window, everything is selected. Just click off, all off, then we can able to see there is no highlight. I am just going to move the pin alone. A symbol we can say. I am just selecting the symbol. Now if we move here, now the line is not being highlighted, but the pin alone is highlighted. So for this reason we have to check the box whenever we take the tools. We have to go to the right side and we have to verify this region. And now I am going to copy and place at X space 50, right? 45 mm, X at 45 and Y of 5. Enter. Then X space 45 and Y of 35. Sorry, 25. Because the total dimension of the board is 50 cross 30 mm. So X space 5 space 25. Okay, now I have placed it. Press enter. I will just dimension the board. Right click. Click edit dimension and get the linear dimension. And select this, and we have to place it over here, and select this width, and I am just placing here. And this another one thing, if you want to delete the dimension, we cannot be able to use this delete option and we can delete, because there is another tool to delete the dimensions. So to do so, go to edit dimension, right click, and there is a name called the delete dimension. If you click that, then this dimension will be highlighted. If you click it, it will be deleted. Now we have placed the mounting drills. Now I am going to import the netlist file. Before that, in the dimension parameters also, we have to verify one thing. Click edit dimension and right click and go to parameters. In that also there is a dimension units. Maintain the same unit and know the unit which you are working on. Here there is a millimeter and lines. That's all. Then click OK. Now I am going to import the netlist. Go to File, Import, Logic. In that I am going to fetch the netlist location. And place in the import directory area. And click once the three dots. And then click OK. Now click OK. Now the directory has been placed here. And select design entry CAS capture. And now just click import Cadence. Yes, there is one thing missed. Actually, we have not placed the user preference. Set up user preference. That pad path. Being placed. Go to File, Import Logic. Software has been closed because of some error. It's successfully completed. There should not be error created. Netlist has been imported successfully. Next, go to place. Going to place, quick place. In that we can able to see total number of components or symbols is 3. Unplaced symbol count is 3. So now I am going to place the symbol. So click place. All the 3 components are being placed. And here also symbol placed is 3 of 3. And then click close. Save once again. Just save in another name because it is creating some other error. Simple one. Next, I am moving the symbol by using move tool and go to the find option, click all off and select symbols, and I'm going to place it over here, resistor, and PTP to rotate, select right click and give rotate. We can able to place the component. Click done. Then I am going to create, save it. Then I am going to create the artwork layer. Go to manufacturer, artwork, and no need of top layer. Just cut it off and select display for visibility. Right click and select display for visibility. In that we have edge bottom, pin bottom, wire glass bottom. And I am going to add another class of board geometry outline and click OK. Now again I am right click and display for visibility, and I am going to add another layer of SM bottom, sound mask bottom. In that we have the unwanted classes and subclasses. Here in the SM bottom we need to add board geometry, outline, package geometry, solder mask bottom, and pin, solder mask bottom, and wire class, solder mask bottom. Then click OK. We no need of etching part in this SM bottom layer, so cut it off and display for visibility. And another layer, SS top, silk screen top. In that I need board geometry, outline, package geometry, silk screen top, reference, silk screen top, then click OK. And next we need another layer called fab. Right click and view, select, create the film of fabrication layer. Click OK. Then we need board geometry, outline, and board geometry dimension. Then click OK. We have created the 4 layers for the single layer PCB. Then click OK. Go to visibility, it should be available, but I'll just close once again and open again. Simple one, double click and Allegro PCB designer, click OK. Now we can able to see the visibility. And next, select the SS top and select all the regimes. Now I am going to connect the wires, that is connect the traces. For that I am going to select add connect and click the option and select the layer in which we are going to do the routing. I am selected bottom and the line of 45 degree and width of the route traces of 1.5 mm, and I am going to connect the traces. Right click and give done. If you want to correct, we can able to use the slide option. Then next I am going to arrange the red dashes. Find text. And then I am going to change the text block so that I should know the information of the which text I can choose. Here I have the text block number 5. I will use the text block 5 and go to edit, change, option, text block 5. So these two also I will just change it to text block 5, and it is very thin, so I am going to add the photo width. I am going to edit the text, design parameter text, and the fifth block, text block, I am going to give the photo width of 0.3 mm, then click OK and OK. Next, if you want to give the name or version, we can able to give it over here. One name of the board, bracket geometry, screen top, and the text block I will just choose 5 itself, and then place over here sample PCB. And then right click and give done. Here we can able to change this color of rough dashes and silk screen layers. To do so, go to package geometry, silk screen top, and right click over here and give. I am giving white color and then rough dash. Screen top, color. Now we have completed the traces and place if needed any text we can have place. Next, I am going to create check the drill customization, NC drill customization, and if we check here. 0.016. The 2 mm drill, just choose triangle and change the name as P. Okay. Now I am going to merge. This total number of drill is drill type is 3 types and the total drills is 10 numbers. So then click OK. Yes. Okay, next I am going to manufacture NC drill In that also we can able to get the NC parameters. Click NC parameter, select enhance echelon format, then close it, then scale factor as 1, then click drill, successfully completed, then close. Next, manufacturer NC drill customization, NC and drill legend, and then click OK. You have to place outside of the PCB boundary. Just place it, and the text is very small. Text block is 9, and I am going to set up design parameter text block 9, and then the photo width of 0.3, and then click OK, and the line manufacturing NC legend go to it. Go to edit, change manufacturing NC legend 102, the line width of 0.3 mm, and select the point that lines, and then select the entire thing, and then click done. So the legend has been created, and I am going to artwork and going to fab and adding the legend layer of drill file. For that, manufacturing NC legend 1 of 2, then click OK, then the gerber of maximum film size of 500 cross 500, mm scale factor 1, film control. That for the fab alone I am just giving undefined line width is of 0.2 mm, and then I will just give OK. And now I will just check the visibility of the layers. To check the visibility of the layers, yes. Bottom layer, only the traces, fabrication layer with details about the drills and the drill chart, and SM bottom, the solder masking regions, and next the SS top, silk screen top, what has to be printed in the silk screen layer. So all the layers are okay. Now I am going to create the gerber file. Go to manufacturer, artwork, and check once again whether the information what we gave before is correct, is available now also. Then go to film control and check database before artwork, and then click create artwork, give yes. So warning, no limit, no film records selected. I have not selected the layers. I have not selected which layer has to create. So I have selected all the layers and just clicking create artwork and give yes. The lock top file has been created. In that we have to go to the last and check it out. Bottom has been created, SM bar created, SS top created, fab created with warnings. Warning doesn't matter, just close it off. Here also we can have to click OK. Save once. Now we have to go to the board folder location and have to get the bottom.r and fab DRL file. SM bar and SM top.r. So cut these files from here and paste it in a separate folder named as Gerber. And now we are going to view the Gerber file which is being created. I am going to use the software name as ViewMed. Go to File, Import, Gerber, then paste the location. In that select all the layers and then click Import. Yes, yes, yes. Now we have successfully imported the Gerber files. If you want to view by layer, we can enable or disable by double clicking at the left side of the window, layers window. Now we are seeing the silk screen top. This is Sonorous bottom, and this is fabrication, that is a drill symbol, and the corresponding symbol will be available here. Corresponding drill information is available here, and the tolerance value, whether it is plated or not plated, and whether it is how much quantity has to be drilled, and the total number of drills, and the dimension of the PCB. Everything we can have to get it, and we have to check whether the drill is being done in only the pins. There should not be extra drills outside the pins. Here that we can have to re-verify when we are having a SM. This is SM bottom and fab layer selected. So fab layer will have the drill information and SM bottom will have the pins alone. So if these two are merged and there is no drill, extra drill outside, then no need to worry, we can able to proceed. The same way for the bottom layers also, we can able to verify. These are all verification procedures. That's it. That's the end. Now we have created the single layer PCB. Then this Gerber file we can able to give to the manufacturer and they will produce the PCB. Right? Thank you.
Ground